All right, welcome ladies and gentlemen. This is video number 4 in our matter unit on separating mixtures, methods of separating mixtures. So you're going to need your notes open to the section that says video number 4. So separating mixtures. Reminder, we use physical changes in physical properties to separate mixtures. Because mixtures, they're simply blends of different things, and you use their physical properties to basically pull them apart. So physical properties, physical changes. So examples of physical properties could be things like color, which is a really easy one if you're just looking at something and you want to separate a mixture. Different colors would indicate different components of the mixture. You could literally use that to separate them. But in chemistry, if you're talking about a mixture that's on a particle level, you could use differences in what is called solubility. So that means how well something dissolves in water. Does it dissolve in water? Because there are things that do not dissolve in water. Density, which you have seen before. I know, like lighter things with that are less dense versus things that are more dense, you can separate them that way. Boiling point. Now remember, boiling point, that is a physical property. Phase changes are all physical properties and physical changes. Particle size, and something called polarity, which essentially is down to the shape of the molecule. So true or false? This is a big question right here. When mixtures are separated, the substances in the mixture are changed into new substances. Well, if you think about salt water, if you were to separate it into the components, you'd get salt and you'd get water. Are those different things than in the mixture? No, they are not. This is very much false. When you separate a mixture, you keep all the components of the mixture exactly the same. You're just not having them be in the same space anymore, right? You're taking the kids out of the pool and shuffling them off to their separate homes, but you're not changing the kids or mutating them in any way. So methods of separating mixtures. We're going to be looking at these different methods in class, but first we have filtration, right? So filtration is a classic example, and filtration separates things based on what is called solubility. So again, does it dissolve? Because if it doesn't dissolve in water, then you would have a liquid and a solid together. So if you have this mixture that is both a liquid and a solid, you can separate it through filtration. And in filtration, you have a funnel. That's what this thing right here is. And inside the funnel, you have a piece of filter paper. If you think of making coffee, coffee actually uses filtration in its simplest form. So I'm not talking about your fancy Keurig cups or anything like that. But if you make coffee, you have this mixture of ground coffee beans that are on top of the filter. That's the solid. So the solid would stay inside. It's trapped by the filter paper. It can't go through the filter paper. But the liquid component of the mixture, which would be like your liquid coffee, can actually flow through the filter paper and gets collected on the bottom. So filtration is a means of separating a mixture that has based on solubility, which typically is going to have a liquid and a solid component. Next up is separatory funnel, and a separatory funnel separates things based on density. And so you have to have two components of your mixture that have different densities. And this is the separatory funnel right here, and this is quite often used for mixes of liquids. And in the separatory funnel, you would pour in your mixture of your liquid, and you would literally let it settle out. Your more dense liquid would go to the bottom, and your less dense liquid would rise to the top. If you almost think about like skimming cream off of a cow milk mixture, that's kind of the idea. The less dense things rise to the top and the more dense things go to the bottom. And then you can quite literally open up the separatory funnel, that's what this does, and very carefully pour off the more dense liquid, leaving the less dense liquid there. So it separates based on density. Next up is distillation. Put some stars around this because this is a pretty big vocab term or idea. And what you need to know is it separates things based on differences in boiling point. So it's a technique that separates mixtures based on differences in boiling point. And you'll notice this distillation setup is a little more involved. The big idea is that we start with our mixture of stuff right here. So in this example, we have salt water, and we want to separate it into the two components of the system. So you heat it. Hey, Bunsen burner, right? So this is your boil it. Let's boil it. But notice that we're not just boiling off the water, that we have this collecting tube that actually, when the water comes up, it's going to boil. But then instead of leaving, it has to go through here. Now it's going to be cooled, and so then it will then condense and be collected in. So the idea is you boil the water, but then collect it, so that you save it. So you don't just boil off the water and you let it go in the air. That's just boiling, versus distillation is separating based on the boiling points, because salt has a significantly higher boiling point. So the salt is going to stay in the flask. Salt stays. The water goes off, but then you collect it. You cool it down, you collect it, and you save it over here. This is what we call the distilled water. You distilled it out of the mixture. So distillation separates on differences in boiling points. We're going to be looking at an example of that in class. I'm going to be showing you a demo of distillation. This is filtration. Now I'm going to be giving you this in class, folding filter paper, because this is sort of a useful skill to have. It involves, you fold it in half, but then you fold it in half again. And then so you have this thing that's in quarters. You then open up the folded quarter thing so that you have one layer on one side and 3 layers on the other, and it makes a lovely little cone, which you can then put into a funnel. So we'll be practicing with this in class, how to fold filter paper. And then finally, decantation, chromatography, and sieves, more methods of separating mixtures. Decantation is another way of separating things based on solubility, so quite often liquids and solids. And this is a ridiculously simple method of separation. You go really, really quickly. And you have your mixture here, right? And you have your solid on the bottom, and then you have your liquid on the top. And decantation literally means pouring off the liquid carefully. So if you had a mixture of, say, sand and water, if you just very carefully poured the water off of the sand so that you kept the sand should stay in this beaker, and you have the water in this one, we have a word for that. It is called decantation, where you're decanting the water off. So this is, it can be a lot faster than things like filtration, which is really, really nice, but it's also a pretty effective means of separation if your solid and your liquid if they don't mix a lot in your beaker. Next up is polarity. So we'll be doing an example of polarity in class. I'm sorry, chromatography, which separates based on polarity. Excuse me. We'll be doing an example of chromatography in class. Again, polarity refers to the shape of a molecule. And we're going to be seeing that later. We're going to be talking a lot more about polarity in our bonding unit. But basically, if you've done paper chromatography before, where you put like an ink spot on, this is our paper. You put like an ink spot here, and then you put it in some water, and over time what happens is the water travels up the paper, and when it does that, it actually separates the ink, which is a mixture, into the different colors that the ink is made of, because the different colors have different shapes, and it tracks the water slightly differently. So chromatography separates on something called polarity. And then lastly, you can use things like a sieve, which separates based on particle size. So this is absolutely another means of separating mixtures.